Welcome again to the course CS565 Intelligent Systems and Interfaces. In this lecture, we are going to discuss initial sets of issues and steps you have to take care of when you begin working in NLP. This becomes, in fact, a very important step if you are starting from scratch or not using any existing annotated data sets. Before we begin, let's recap what we discussed in the last lecture. We have discussed what do we mean by NLP, the two different school of thoughts, the empirical, empiricist and rationalist, which help in progress in NLP research. In fact, you are going to see a glimpse of the influences of these two schools in our today's lectures as well. And we have also discussed the ambiguities present at different levels of NLP, which makes automatic processing of the natural languages hard. As I mentioned, this lecture discusses essentially the basic resources, the pre-processing steps, and the tools required for almost all tasks involving NLP, irrespective of what is the final target course. In particular, we begin our discussion on corpus, the first resource we require for NLP work. Then we will move on to the essential pre-processing and normalization steps required for further processing. So let's get started. So if you remember, we have discussed in the last class that this course primarily focus on empiricist or more inclined towards the empiricist approach, and that approach requires large collections of the data, and in fact, you can say that the statistical NLP is perhaps one of the first examples of successful use of big data. Although at that time nobody really mentioned the term big data. Uh, so let's see that what is the huge collection of the data it essentially requires. What it requires is a large collection of the text containing often billion words, and it is sort of produced by the users. Now, these users can be the authors. These users can be related to the newspaper articles, the fiction writers, and so on. Uh, and they can be used for several purposes. For example, analyzing how words, phrases, or language is used in general, how it has evolved. They can be used for several applications, such as predicting next words, learning vector representation of words, spell checkers, the grammar corrections, name entity recognition, event identification, etc. So that these corpus can be used or can be made for very targeted objective, or can be used or can be made for a general perspective. Uh, there are different types of the corpora which you can come across. However, the most common types is the monolingual corpora. That means that it contains a text from a single language. Then there are parallel corpus. There are varieties of the parallel corpus, corpora. So corpora is basically is a plural for corpus, and in its pure form, the parallel corpus consists of the two main monolingual corpora. One is translation of the other, and again, in its most pure form, these two languages are aligned. That is, corresponding segments, the sentences or the paragraphs, they are actually matched. Uh, then there are this multilingual corpus, which is a type of a parallel corpora, but now it does not only limit to two languages. It consists of several languages, and again they are all translations of the same text, and are aligned in the same way as in parallel corpora in its pure form. So again, this is what I'm saying is this is an example of multilingual corpora in its pure form. Often there are corpora which are not exact translations, and so those are in fact called as a comparable corpus, which is again is a set of two or more monolingual corpora, generally in distinct languages, and generated created based on the same principle. The content is expected to be very similar and can be compared. However, they are not translations of each other. They are not matched or aligned. So you can think of Wikipedia articles on a particular topic in different languages. Uh, so that is a good example of comparable corpora. Uh, uh, again, you know, uh, for the sake of the definition, maybe we can say that the parallel multilingual corpora in its pure form, they are aligned, matched, and translations of each other. Uh, the comparable corpora is a kind of a parallel corpora where it's where this alignment or the matching is not done, but you can still comparable because the way uh, the multilingual text has been generated, they are based on the similar principle and thus can be compared. Then there are very specialized corpus like a learner corpus, which is a corpus of the text produced by learners of the language. The corpus is helpful in studying what common mistakes learners make and what kind of a problems they generally face. And it's a good for if you want to build a spell checker or grammar correction models, this kind of corpus is generally quite useful. Then the diachronic corpus, which is a corpus containing text from different time periods, and such corpus helps in studying the language evolution. And on top of this, some of these corporas are highly specialized uh, and maybe designed for a particular uh, purpose, and some of them are has a sort of a multiple layer of annotations available and can be used for from basic processing to higher level of NLP applications. Um, and on other side, there are corpus which are simply containing raw text, and then depending on your target applications, you work on them and you make you process them, you annotate them as per your requirement, and then you can use it for your target applications. Most of the corpora are results of organizational or consistent efforts. So some of such efforts are listed here, or some of these organizations which has involved in creating large collections of corpora Linguistic Data Consortium, LDC. Many of their corporas are freely available, and then some of them are only available for members or on the basis of payment. Uh, then there's the European Language Resource Association. We have the Indian language, specific to the Indian languages. Also, there are efforts to generate these corpus. And then there are a few individual efforts to create a specific type of a corpora. So, for example, our group has created one corpus on the based on the Wikipedia text for fine-grained entity recognition. So that is sort of a generated for a very specific objective. Uh, So in this table, you can see some classical examples of the corpora, which have been traditionally used for several NLP pre-processing tasks. One of the first ones, perhaps, is the Brown corpus, created in 1961 in the Brown University, containing about 1 million tokens, uh, 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 and these tokens are coming from about 500 samples of the English text, and these are coming from multiple genres, including news articles, fiction, non-fiction, academic articles, etc. The Google Ngram is the first one, which the based on which you earlier, before the neural models were being used for such purpose, the Google Ngram data was sort of used to predict the next word in your search queries, which is the predicting the next words or the phrases. And so this is the one which was sort of used, which was used to suggest the next words. And here you see that there are two things. I'm using the word tokens and the type. So let's discuss that what is the difference between the two. So the tokens are the number of running words, and the types are the number of distinct words in a particular corpus. So the distinct words is the types, and of course this would be lesser than the number of tokens, which are all the words which are there. So if a particular word is appearing 2 times or 3 times, so while you are looking at the tokens, it will be counted 2 times or 3 times, depending on how many times that particular word has appeared. Uh, but while counting as a word type, then it will be counted as just one. You can access many of these corpora from tools like NLTK, and then there are several databases are available from where you can create a very specific kind of a corpus. So the PubMed research articles, free text from web, social media platforms, and so on. And often, some of these conferences, which organizes a specific NLP task challenges, and then they create a very specific corpus for that purpose. So, for example, to mine the COVID-19 related entities or events, the COD-19, it's I think about millions or thousands to the millions of the research articles, which some of them are already peer reviewed and published, and some of them are in archive kind of publications. So people have used this data to really understand uh, uh, several aspects related to the SARS, the novel, the corona virus. So again, so why I have given these examples to make you understand that just having an access of a one particular corpus is not sufficient, because each corpus has been built for a specific purpose. It may be good for you, but it may not be sufficient for you. So you need to always remember and see that what is your objective, and accordingly you try to find out your the relevant corpus. And if sometimes such corpus are not available, or even if it is available, it may not be sufficient for your target task. So for example, as I mentioned, that we have created this Wikipedia based corpus for fine grained entity types. So there were some data sets already available, but they were not available for fine-grained entity types. So that is the reason that we have to create our own. So we have now already discussed that what is the basic resource required. So that is the large collection of the text. So that is a corpus. So let's assume that now we have available that, and what are the, let's say that if it is already pre-processed, but then while creating such corpus, the the people or the group which has created those corpus, they had to go through certain pre-processing steps. So let's try to understand that what are those pre-processing steps, so that like when you have to create such corpus for your own purpose, you are aware of it. And in fact, even though let's say that you are already working with something which is already provided to you, and it's a clean, relatively clean, and when you try to analyze some of the errors which you are observing in your models, uh, if you don't have the clear understanding of in what way the data was pre-processed, you may not be able to understand a few of the errors and how to take care of that. I mean, I will try to highlight at in our discussion later on some of those important things. So let's discuss that what are the important pre-processing steps which are there. And often, we try to we ignore these kind of a basic and low level pre-processing aspects, but then it becomes very relevant when you have to build your own corpus or perform error analysis, and for that matter you're trying to analyze to you want to do the analysis for to explain your results. And this has become even more relevant with the neural approaches, because the neural approaches generally you don't focus on designing features. And when you design features, so when you're working with the classical machine learning methods, then you try to design features, and while designing features you may understand the kind of the data, the raw text which is there. But if we are using the neural approaches, we directly go with the vector representation of the words and then the text. So we don't really understand that what is inside those data. Uh, so the first thing is when you are working with the raw text, if you have collected it from some sources, there may be some the additional tags, maybe for example like XML or HTML tags, document headers, separators, tables, diagrams, etc. So you need to sort of remove those text, extra text. Sometimes some of those tags are very informative, and again, depending on the nature of your work, you may want to keep them as a meta informations in separate file, but in actual purpose, you may just want to keep the actual or the text which are relevant. The text normalizations deals with bringing text into a standard form. Three main normalization steps are generally performed, while the first two focuses on recognizing the or identifying the word and sentence boundaries. The another normalization deals with the bringing various word surface forms into one of their standard form. So the examples like this, like if you have the spelling variations, whether you want to do make everything in small case letters, whether you want to find out what is the lemma for each of the words. So you take the words and then convert them into its lemma. The stemming, it's some sort of a crude form of lemmatizations. I will discuss this in a bit more detail. And then you also may want to do some sort of a morphological analysis and do the morphological parsing of the of all the words. So depending on again your target goal, some and on in fact all of the nomination steps may be important. So let's discuss them one by one. So starting with how we are going to find out the word boundaries. So the tokenization is basically the process to divide the input text into units, also called tokens, where each is either a word or a number or a punctuation mark. Uh, So while it is easy to understand and define numbers and punctuations, it is difficult to define what counts as a word. Often this definition needs modification to take care of text from a specific genre. For example, like if you are dealing with a social media text, you have to be very careful, like a Twitter or Facebook, and so on. So you may have to sort of redefine your definition of a word. uh, Again, I will highlight some of these aspects in due course of our discussions. But let's begin with the simple case when we have something like this, where I mentioned that I am interested uh, in natural language processing, but I'm not sure of the required prerequisites. Now, in this given sentence, the question is, what are the things which can be counted as a word? Should I count punctuation as a word? Should I treat I am as one word or break them into three words? One is I, then the apostrophe and M. Or should I consider the natural language processing as one word or three words? Uh, so in this case of the IM, this is sort of the way it is written. It's called the clitic. Uh, so the clitic is basically uh, a part of word that does not have its own meaning unless attached to another word. So the the single letter M or with apostrophe M, it does not have any meaning, and these are called clitic. But when it joins with I, then it sort of translates, or it means that I am. Uh, so again, should I treat this entire thing as a one word, or should it be broken them into the smaller components? Regarding punctuation, in the layman intuition says that maybe we can remove punctuations, or at least which is lying within a sentence, such as comma or dashes. However, depending on the task, they do contain relevant informations. So for example, if I'm interested about a part of speech tagging, then maybe the having these punctuations and other information is helpful. But if you are I'm looking at the web search queries and I want to retrieve such informations, in those contexts, perhaps removing the punctuation is okay. So given this kind of a situation, people try to come up with some sort of a definition that what we can call a word or the graphic word, so that excludes the numbers and other things, punctuations. So the Coursera and Francis, which actually has created this brown corpus, has defined a word as a string of contiguous alphanumeric characters with space on either side, and it may include hyphens and apostrophes, but no other punctuation marks. However, such definition has certain issues. So if you look into, if you are considering which are something like the numbers, or there's some special characters which are appearing between mm, as one of the characters in word, or things like the specific symbols, the smileys or emoticons, this hashtags while you are considering the forums like Twitter, etc. Uh, so they may not, exactly obey this definition of the word defined by Kushida and his colleague. Uh, so uh, so depending on the context or your application, you may have to redefine it. So one of the heuristics you can take, because see, you need to sort of remember that the tokenization is perhaps one of the very first step you have to perform while dealing with natural language text, and you want this process to be very fast, and you may be ready to take care or willing to sort of take some sort of a noise in that process. So maybe let's look into that, how this simple heuristic of separating based on white space. You can say that it could be a space or tab or the new line, which is sort of separating or the segmenting the word boundaries. Let's again look into that, this simple heuristics, what kind of issues it can cause, and can we think of take care of them, and maybe perhaps that I will highlight few points, but then maybe this can be a part of your first assignment, that how you can enhance such kind of a simple heuristics to reduce the noise. Uh, so, you know, the words not always surrounded by white spaces, often punctuation marks such as commas and columnar periods come. So, for example, the specific thing you can look into is the period. So now, in this particular example, this the was with the period versus was. So now, if I remove this punctuation mark, dot, and then try to consider this was versus the was to sort of the cleaning of your clothes or something like that. So but here when it says the was dot, so it is perhaps signifying the place called Washington, and taking out the period changes its meaning, and it can create a problem. Then the periods are used, here in this particular example also it has used to sort of abbreviate Washington, but it may sometimes come at the end, or sometimes it comes in the middle. So how we are going to take care of this, and you have to think that whether there are other clues which can help you to take care of this challenge. Then you have this issue of uses of these apostrophes. You remember that I have talked about this clitic, and that clitic or this kind of a contraction should be taken as one word or the two words. And I also see that how, if you, even if you decide, for example, the pen tree bank is another example of the corpus, which is a very very important corpus. It actually splits such contractions. So that means that it will break them into I and M in case of IM. So if you follow such kind of rules, then how you are going to deal with the cases where the dogs, of course, this can be broken down in, but then what you do when it is written as a, in this particular sentence, the house I rented yesterday's garden is really big. So here, if you try to break them or into the two words, then it completely changes the meaning. And here you should not be breaking them. Uh, with respect to the hyphenation, we observe very similar situation as we have discussed for periods. So this question remains the same. The do questions of do sequences of letters with a hyphen in between count as one word or two. So occurrences like email with a hyphen between e and mail, corporate hyphen between co and operate. Should I consider it as a single word? So all of you perhaps agree that we can consider them as a single word. While words like non-lawyer, so-called, they should not be. Now, the question is, you have to sort of come up with a uh, heuristics or the rules which can do such separation. And of course, the inconsistencies, like where the email might be coming without hyphenation, cooperate coming without an hyphenation and hyphenation, so that can be taken care in the subsequent stages of the normalization. Uh, but questions like the line breaking hyphen versus actual hyphen. So line breaking hyphen is that when it happens that there is some word, but it comes towards the end of a line. So some characters of that particular word is in the one line and another ones is the second line, and so there is an hyphen. So that means that those hyphenation needs to be removed. But there are some actual hyphen. For example, if email is occurring at that position and with hyphenation, so in that case the e is in the end of the line with hyphenation and then mail occurs. So there we cannot perhaps remove. And this kind of a situation calls the haplology also, that you don't put two hyphen to indicate that okay, this is something which is happening at the end of the line, as well as the actual hyphen should also be there. Similarly, this situation appears for the period case as well. So for example, etc. is coming at the end of a sentence. So for end of a sentence, you need to put a one full stop or period, and for etc also requires one. So you don't put two full stops there. You just have one, and that similar situation happens here in hyphenation as well. So you can perhaps have a very similar rule to take care for both of the cases, for period and as well as in hyphenation. And sometimes that we try to emphasize the grouping of the word by putting a hyphenation. And again, those hyphenations in ideal scenario or in actual sense should not be there. So those should be considered as a you should take them as a separate words. So again, now the question comes that how you will decide that in which case you should keep the hyphen, which case you should not keep an hyphen. So you have to come up with the set of the rules perhaps, and accordingly you can try to take care of it. Some of the heuristics may in some corpus will work nicely, but in some corpus it may not, and then there will be some noise data. You may like to keep them, and you can sort of try to ignore them as dependent on, let's say, that what is the ultimate objective. So again, there are like, see, we are talking about a heuristic where we are separating words or the word boundaries, identifying the word boundaries with some white space characters. Now, remember the first sentence we have written where we have this natural language processing. Should I consider them as a uh, one word or it's the three word? The words like the New Delhi, San Francisco. So then these words are actually some tokenization more mm, algorithms might want to keep them as a uh, two separate words, New and Delhi, and then in the subsequent steps perhaps they will try to club them. In some tokenizations they will try to sort of combine them, or in the first step of the let's say tokenization they will try to put them separately, and then they will do something like co-location, as we will discuss it in the in next or after few lectures. So in that case, we will see that such kind of situation can be taken care of. But the situations like the New Delhi hyphen. So now this is like you have this white space situation as well as this hyphenation situation, and that comes together. And again, you may want to sort of you have to sort of be careful that how this issues can be taken care of, because here if you take Delhi hyphen new, if you want to keep it in a separate word or if you want to join them, that is going to impact. For example, if your ultimate goal is the name entity recognition, so then the boundary of the entities as well as the perhaps the boundary of the entities will not be detected correctly. So and when you try to no matter, let's say, that how good your model is, those models is going to fail in such scenario. So and then when you try to do the error analysis, if you are not aware that such situation can come, you will be not be able to sort of take care or explain those errors. So so any of these the rules or the heuristics you have to come up with, so that you can take care of most of these problems and the issues. But still some of the issues will remain there, and you have to be aware of those things, so that you can try to understand that what is the model can do and what is the model perhaps cannot do, because that may not be the actually the capability of or the ability of the model to take care of those errors. Let's also briefly look at some issues you have to handle or you have to take care when you are dealing with the spoken corpora. So this sentence here, you see that this lecture is mainly divided into two components. So in this case, there are two types of the discrepancies, or you can say the issues. One is that the fragments, like the mainly, basically the word is the mainly, but as we speak, we have this tendency sometimes to only keep the fragment, and then subsequently we try to complete that word. And in fact, while watching this video, you may have already found out and may have noticed so many discrepancies in my narration. Then second type of the discrepancy is that we have this kind of pauses or the fillers, so that those are the projects. So in the the spoken corpora keeps everything, and a good way to understand this is that in your while you are watching in this in YouTube, if you ask it to show the subtitles, you will see whatever I am speaking, and all these the fillers and the fragments are actually you will be able to see there. So now, if you have such kind of a transcription, and then you have to sort of define that whether you should consider such kind of a discrepancies or you should remove them. So again, it will depend on your the final objective, that whether it should be there or not. So for example, if it is just a speech transcription, so then you may want to remove such kind of discrepancies. Uh, but if it is the task of the speech recognition or speaker verification, then you may want to keep them. For example, speaker verification, people have observed that different people use different type of the fillers. So, the way I speak and then the way I have, let's say, these fillers, it is it will not be the same as in your case. And so that keeps a important signals or the features that can be an important feature to sort of use for the speaker verification. So again, to highlight that, when you're so there are two things I want to sort of emphasize here is that one is that it depends on your purpose and your object, the ultimate objective, what you want to do, and based on that, you perhaps decide that what you are going to consider as a word and which would be the suitable heuristics you need to sort of apply to get the tokenizations done on a given corpus. What I have highlighted in my all this discussion is that the issues when you are trying to define or find out that what is the word boundary, and if you decide a very simple heuristic, then what kind of an issues can come up. So what people have done that since it is if it is an important or let's say that essential or very first step to work with any kind of a text data, you want this tokenization to be very very fast, and you are willing to perhaps take a little bit of error into that you can perhaps based on your application you can take care of those errors later on. So mostly, the tokenizations have these deterministic algorithms which are based on these regular expressions. So regular expressions try to, uh, consider all your the heuristics, and then you convert them into the regular expressions, and based on that, you try to tokenize your corpus. And in the libraries and the tools is basically compiled into the efficient finite state automata. So again, as per the first assignment, I would ask you to go into some kind of this model to come up with or you can write your own finite state automata for such kind of tokenizations. So until now, we have discussed about tokenizations, which are uh, good for languages like English, but there are certain languages like Chinese, Japanese, which have no spaces between words. So how to do the tokenizations for such cases? Of course, in recent times, there are, you know, and there is a tendency to work at the character levels. But that is like, it's not that the only people only work with the character levels, but for in some cases like Chinese and such languages, people have seen that working with at the character level only perhaps is sufficient for many NLP applications. Uh, but still, this is a challenge. And in recent times, there are some neural models which has people have come up with and to do the word segmentation for such languages. And specifically the Japanese, which is gets further complicated because they have these multiple alphabets and which are actually intermingled. So that makes the task even difficult. And then there are languages. In fact, the Indian languages are the examples of such languages where we have the word, a single word, which is basically made of joining multiple constituent words. So now, to get the meaning of it, perhaps you need to break them into the respective constituent word, and then you can do the further processing. So now the question is that how you are going to do the segmentation in such cases. So that puts another challenge for such languages. Thus, this brings us to the end of this lecture, and In the next lecture, I am going to discuss the other two normalization steps, consisting of the first part would be on the sentence segmentation, and the second would be we will be talk about the other normalization, that is basically the word level normalizations. For example, uh, handling with cases, lemmatization, stemming, and a little bit on the morphological analysis. Uh, yeah, so that's the end of this lecture.